pandemic. My name is Frederica Diastra. It is my pleasure to welcome you to this webinar, Disaster Resilient Infrastructure, Indonesia Mega Project Navigating Through Various Challenges. This is the first series of international webinar brought to you by the Asian Civil Engineering Coordinating Council, ACECC, in collaboration with FIB YMG, Young Members Group, Indonesia. Before we start, I would like to thank you for joining us today on Zoom. This webinar will be about 1 hour, consisting of 3 15-minute presentations, followed by 15 minutes discussions. If you have any questions, please type in the comment box below. Please introduce yourself and to whom the question is addressed to. Perhaps before we start the session, I would like to give a brief information about ACECC and FIB Young Member Groups, the event organizer of today's webinar. ACECC, the Asian Civil Engineering Coordinating Council, was established in 27th of September 1999 in Tokyo. The aim is to promote collaborative work towards sustainable development of infrastructure within the Asian regions. Part of the ACECC, the ACECC Future Leaders is a group of young engineers below 35 from across Asia Pacific, with representatives from 14 members economies, aiming to develop leadership skills in young civil engineers by creating and promoting Sustainable Future Leadership Forum, the first and inclusive culture for young civil engineers in ACECC member economies. Each month, the ACECC organizes international webinars hosted by different countries of the future leaders. This time, the webinar is hosted by Indonesia. The next webinar will be hosted by Nepal in June. Just save the date. That will be next month in June. All right, ladies and gentlemen, today's webinar is brought to you by the ACECC in collaboration with FIB YMG. The FIB, Fédération Internationale du Béton, was formed in 1998 by the merger of the Euro International Committee for Concrete and the International Federation for Pre-Stressing, FIP. It is a not-for-profit association formed by 41 national member groups in 104 countries and approximately 1,000 corporate and individual members. The FIB also have Young Members Group, a special form of commissions, which provides a medium for young professionals in civil engineering to exchange the knowledge and experience and to establish a wide professional network. To deliver the mission, the FIB YMG also organized webinars with broad interesting topic in civil engineering area. Some of the past webinars, for example, discussed tunnel structures, long span bridges, and building information modeling, and many more to come, hopefully in the future, with the fascinating topics. And we would like to welcome you to all of our next coming events. Ladies and gentlemen, the Asia region has achieved major economic growth and poverty reduction over the past recent decades. Infrastructure has played a key role in this success. However, we often experience extreme disaster where infrastructure is one of the first aspects in the built environment being impacted with direct impact on life, economic growth, and viability. It is therefore a need not only to ensure the investment in infrastructure is more resilient, but also to enhance the infrastructure itself and protect them against major events such as earthquakes, ground movement, and liquefacions. In today's webinar, we will learn from various disaster-related challenges in Indonesia mega projects. We have invited 4 honorable speakers with 3 interesting topics to be presented to you. The first speaker is Dr. Daniel Hutabarat, a postdoctoral researcher in Pacific Earthquake Engineering Research Center in University of California, Berkeley, with his presentation entitled Geotechnical Aspect for Disaster Resilient Infrastructure in Indonesia. The second presentation will be delivered by 2 speakers, Mr. Vincent Yosafat, Butarbutar, and Mr. Alve Yunus, the construction manager and engineering manager at WICA Indonesia. Mr. Vincent and Mr. Alve Yunus will present to us settlement and deformation observation and evaluation analysis of Jakarta-Bandung high-speed train project. And our third speaker is Mr. Kirana Rongsadi from PT Geotechnical Engineering Consultant. Will present evaluation of the degree of consolidation of coastal reclaimed land based on settlement data and CPTU, Makassar Reclammation Project. Ladies and gentlemen, I would like to welcome you, our first speaker, Dr. Daniel Hutabarat, who is already here with us online. Dr. Daniel, good afternoon from us from Indonesia. I guess good evening there in California, right?
Exactly. So good afternoon, Asia.
Yeah, Dr. Daniel gained his PhD from UC Berkeley. He has 5 years of professional experience with expertise, including computational geomechanics, earthquakes engineering, soil improvement, and foundation engineering. Mr. Daniel, I hand over this platform to you.
So should I share my screen now?
Yes, please.
So can you see my screen?
Yep, it's okay.
Okay. So thank you very much for the kind introduction. And it's such an honor for me to be invited to be one of the speaker in this energetic webinar where all the future young leaders are gathered together. So today, I think I want to talk about an approach where how we can assess a seismic risk assessment better, which is using a performance-based design. And I also want to discuss about geotechnical aspect for disaster resilient infrastructure and how we can approach all the uncertainty that's happen at the sites and how we can quantify all the variability so we can provide a good design. So before I would like to start by showing this unprecedented scale of ground movement during the Palu earthquake. So I visited the site like maybe a couple of days after the earthquake to study, to investigate what happened at the site. So we can see here where the ground moved due to earthquake, of course, due to soil liquefaction. And we know that the damaged area is about 2 kilometers square. So this is a big, massive ground movement. So when I visited the site, one question that I have in my mind is, do you think any individual ever imagined this unprecedented scale of ground movement could happen in Palu? And I think no one. So that's one questions. That's a really important questions, which indicates that I think the risk assessment is very important, and all possible events that should happen or can possibly happen should be quantified, should be analyzed. So this type of unprecedented scale of ground movement should not happen anymore in the future. So as an engineer, we are pushed by users, by owners, or by all our clients to inform them what are the risks that we are dealing with, and we always be asking about three fundamental questions. So the first question is, what events could affect the performance and safety? Events like earthquake or flood, landslide, and fire. And the second is, how likely are those events to occur? So we're talking about the probability of occurrence. So how likely it happens in a year. So I call it here lambda, where I will use these variables later in these presentations, and we call it annual rate. And the third question is the what are their consequences? How many people will die? And repair costs, economic damages. So We are, as an engineer, we are at the center of the circles. So we know everything. We know the mechanics, we know the science. So we can, only us who can communicate all the hazard to owners, operators, users, to policymakers, economists, scientists, and everyone. So in these presentations, I would like to give us an example and how we can assess a risk, a holistic risk assessment approach in a simple project. So I would take an example. It's like hypothetical example. So let's say we want to build a railway track on embankment, and the embankment was underlain by alluvial liquefiable soil. And let's say the yield acceleration is about zero point 0.2 g. And the question is, uh, how large the slope will displace if earthquake happens. And we have two level sites of investigations, where one we have a field measurement, and the second one we only take some uh, empirical correlations from any test, so we can estimate the stiffness of the under the foundation soil. So this is the example of the shear wave velocity, which is basically the shear modulus, how steep the soil will propagate the seismic wave during the earthquake. So on the left here, this is a measured in situ parameters where the variability is narrower compared to the right plots, where the right plot is a estimated shear wave velocity if we use a cone penetration test type of correlations, and it has a higher variability compared to the left one. So we will we will deal with this type of two data, and then we want to assess what is the risk. So in risk-informed engineering decision-making process, especially in earthquake, so when earthquake happens, it will generate a ground motions, where the ground motions, the role from the engineering seismologist, the concern is how likely a 0.2 GPGA to occur, which is a level of accelerations that can yield the slope, and then the slope can displace. And then the ground motions, of course, will excite the systems such as slope or such as a buildings, where we are as a geotechnical or structural engineer. The concern is how large the lateral deformation is. And of course, after the system is response, we want to quantify the physical damage. While here, the damage estimator or the repair contractor, and they're concerned about how large the railway will offset. And of course, losses from the government and owner, the concern is how much the repair costs. So how do we communicate all these steps of the process, and then we can take a decision to design our project. So that's the topic of my presentation today. So in my institution now, which is the Pacific Earthquake Engineering Research Center, we have a framework, it's called a performance-based design framework, where the ground motions that is occurred during the earthquake, we call it an intensity measure. For example, it's a PGA. And then from there, we can do response simulations to obtain how the system will respond. And then we can quantify the engineering demand parameter, or called EDP, which is the lateral displacement, like slope displacement. And of course, the damage measured from the physical damage, how far the rail will be offset and out of straightness, where that will determine the repair cost, which is the decision variable DV, as a basis for the owner to take decision about the projects. So the peer performance based recovery engineering basically is a very simple approach, where when earthquake happens, we want to know what is the intensity measure by performing hazard analysis. So we are doing a like seismic hazard analysis, where the vertical axis here, the lambda is the frequency, the annual rate an earthquake will happen, and the x-axis here is the magnitude of the earthquake. I mean the accelerations of the earthquake. So we can see here the higher accelerations, the lower annual rate. So it will occur less frequently compared to lower PGA. And then we know the PGA, we can estimate the slope displacement by using a response model like finite element analysis or limit equilibrium analysis. You can choose either one of them. And then we perform simulations by performing a PGA, we increase the PGA, and then we can estimate the slope displacement. Of course, we have variability. This capture variability, and then we can estimate the model. And then for the railway offset, we know the damage model, and then we can estimate by slope displacement. We know how much the offset, and then from the offset, DV, we have a loss model, and then from the railway offset, we get the repair cost, which is also, we have a variability. So as the offset gets uh, very, very large, of course, the cost will be asymptotically rich value, and which makes sense, right? So how to calculate this? So let's imagine we have like a 5 possible peak ground accelerations, like 0.1 g to 0.5 g. And then let's say this is what happened. When earthquake happens, it generates IM3, let's say zero point 0.2 g. From IM3, it generates like 25 centimeter of slope displacement, which is the EDP4. And then 25 centimeter of slope displacement will cause about 10 centimeter of railway offset, and then from 10 centimeter railway offset, we can estimate maybe about $1 million of repair costs. But so the probability of $1 million will be used as to repair this railway. It's going to be the probability from the white color here, which is the earthquake from here, and then the probability multiplied by the probability of how much how the PGA will cause a slope displacement, and then multiply again by the green color, which is this step, and then multiply again by the yellow color, which is this step, which is the probability of the damage measure 1, 20, 25, 10 centimeter railway offset, and to cost a $1 million repair cost. But it's only one best scenario, and the key of quantifying risk is we need to consider all the risks here. So how to calculate this? This is like but even though it looks like so difficult, but this is just like a summing all the possible events. And then, so from right to the left, the white one is a seismic hazard curve, which is we can get from hazard map, for example, a seismic hazard map of Indonesia. We can generate a model, we perform deformation analysis, and then we know the probability of accidents from a specific IM to cause a significant ADP. And then from ADP, we also get a damage model, and then we keep multiplying them until, and then we also have loss model, and then finally we get the loss curve. For example, loss curve for a specific projects that I've been dealing with this is one of the examples. So remember, I have two data of soil investigations. The blue color here is the annual probability that the owner will spend the cost. For example, for 0.0001 here, it means it's for a return period of 1,000 years. So the owner will spend about 160 millions if they use a cheap design where they didn't know soil investigation, they didn't hire any expert, and it has a very high uncertainty. And if the owner choose a better design, well, it has a high quality soil investigation with lower uncertainty, the cost will decrease to the left. As you can see from here, the probability of during for the 1,000 years to spend a repair cost reduced from 160 million dropped to 77 million dollars. So by using this approach, we can communicate our analysis better to the owner or to all stakeholders. And so to summarize, this is an approach to quantify all the risks. And sometimes we forget all this big picture because we were trained to be in this box where we want to know the slope displacement, or maybe in any other cases like settlement, and then for physical damage, where the structural engineer will focus on like a building collapse or a slab or drift, I don't drift ratio or something like that. So we are trapped in these boxes where the big picture is bigger. So to summarize, so the key takeaway is I think we should always think probabilistically in terms of we always keep asking, what if this happened, what if that happened? So we need to consider all can happen. So the type of event like the one that happens in Palu will not happen again. And the second is hazard resiliency. Is all about risk estimation and loss prevention. So by using this approach, using the framework that is established in PEER, this framework is a well-established alternative approach to perform hazard resiliency evaluations. And of course, engineer always deal with full of uncertainty. I think this is the key. The challenge in any projects, either it's geotechnical engineers or structural engineers, it's uncertainty because we're dealing with a geological materials. It's full of uncertainty. So I would like to close this as with a powerful quote, which is risk is a measurable uncertainty, but uncertainty is unmeasurable risk. So if we can measure anything, we can measure the risk. So I will to close. I would like also to remind all of us that we also have an ethics. We also have a code of ethics for engineers, and this is from U.S. Engineers from in the U.S., where the fundamental canon number 1, which is also the our first priority, that engineer shall hold paramount the safety, health, and welfare of the public. So thank you so much for the opportunity. And then I think I will give back to Derek to take this webinar. So if you have any questions, if you want to contact me, this is my email address. So I would love to answer that. Thank you so much.
Thank you very much, Dr. Daniel, for a very nice and informative presentations. All right, and I would like to remind all of the audience, if you have any questions, please just type in the comment box below, and please introduce yourself and to whom the question is addressed to. Okay, next we go on to the second presentations. The second presentation entitled Settlement and Deformation Observations and Evaluation Analysis of Jakarta-Bandung High-Speed Train Project. We will be delivered by Mr. Alve Yunus and Mr. Vincent Yosafat Butarbutar, who are all joining us now here as well. Mr. Alve Yunus and Mr. Vincent are experienced civil engineer with several years experience in industry, working on some prestigious infrastructure projects in Indonesia. They are now currently working as engineer manager and construction manager at Wika, Indonesia. Ladies and gentlemen, please welcome Mr. Alve Yunus and Mr. Vincent.
Okay, thank you for the kind introduction from Mr. Derek. Good afternoon, everyone. It's an honor for us that we can be the speaker of this webinar by ACECC. Nowadays, infrastructure has become one of the main focus of development and improvement in Indonesia. Hence, now we are faced by various mega projects with different challenges on each project. But who here know what kind of challenges that we must encounter in one of mega project in Indonesia? To answer that, let us introduce ourselves. I'm Vincent Butarbutar, currently enrolled as construction manager, and my colleague Alve Yunus as engineering manager at Jakarta-Bandung High-Speed Railway Project PT Wijaya Karya. We are now in charge of one of the most noteworthy projects happening in Indonesia. For the first brief introduction of our project will be presented by Mr. Alve.
Okay, thank you, Vincent. So your screen is already seen, right? Okay, yeah, kelihatan. Okay, thank you. Okay, thank you guys. my name is Alve. I just want to maybe this is some kind of what's happening now in our project, and then maybe we can discuss about it a little bit. So first of all, I want to introduce you about the project itself. So maybe the Jakarta-Bandung high-speed railway itself is considered for the high-speed railway first in Asia. Okay, so the length of this railway is 142 kilometers, crossing onto province, and it has 4 station NTODs, and it crosses in 6 cities of the or region in Indonesia. So the project name itself is Jakarta-Bandung High Speed Railway, or we call it GBHSR, GBHSR, and then the project owner is PT KCIC, Kereta Cepat Indonesia Cina, and then the contract value of the joint operation itself is around 4.71 billion US dollar, or in Indonesia rupiah is about 62.83 trillion rupiah. And our company itself, PT Wijaya Karya, has a 30% of portion, so the value is about 1.4 billion US dollar, or maybe around 19 trillion Indonesian rupiah. So the contractor itself in this project is High Speed Railway Contractor Consortium. The member is some of the members from China and also from Indonesia. So we have CREC for the project management, we have CRDC for the design work, and we have CRSC for the signaling work, and then we have CRRC for the rolling stock of the train, yeah, and then we have CREC, maybe it is considered as one of the biggest contractor in the world, yeah, and then Sinohydro, and last is Wika. Okay, so the funding of this project is 20% from the equity from each member, and then 70% is loan from China Development Bank. Okay, so this is the business scheme of this project. The PKCIC has two member, yeah. This is the Chinese consortium, and this is the Indonesian owned state company consortium. So from the Indonesian side, it has 60% of portion, and then the Chinese side is 40% of portion. And after that, on the contractor consortium itself, there are Chinese company and Indonesia company. So for the civil contractor, we have three contractors that I have mentioned before. These are Sinohydro, CREC, and Wika. Okay, this project has about 14 tunnel area, 46 bridge area, 55 sublet area, and 4 station area. So from the 142 kilometers, the bridge elevated is 83 kilometer, and the sublet is 41 kilometer, and the tunnel is 16 kilometer. So this is the trace of our project from Halim to Bandung and Tegaluar. It has 4 stations, and it divided by 4 sections: section 1, section 2, section 3, and section 4. So that on Wika scope of work for whole the structure, Wika has 30% of the portion. So you'll see the blue color is Wika portion, and the red color is Chinese portion. So for the continuous bridge, the portion of Wika is 30%, and the elevated bridge is 40%. For the pier column, in the whole project from Jakarta to Bandung, Wika has 100% of portion. So about 2,500 piers. Yeah. So for the tunnel work is all the Chinese portion, and for the subjet Wika has 96 of portion. So from Wika scope of work itself, it has 1,200 pile cap and 12,000 of bore pile, 155 work schedule cash inside, and 4 continuous beam structure. And then also Wika portion is 3 station, and then for the subgrade work, there are 69,000 of spoon pile, 6 million cubic meter of excavation, and 3.5 million square meter of engineering. Okay, up to last year, the progress of the project itself is about 66%. And then this is the design of the station. This is the TOD. This is the temporary facility that we have made in this project to support the construction. And we have also our central laboratory and okay, in Cikarang, DK on high-speed railway, it's same as station. So maybe DK 32 means that this is the stationing on 32 kilometers. So for the general requirement will be I will be give to Vincent, yeah. So
Okay, thank you, Alve. For the general requirement, I will explain to you. Jakarta-Bandung high-speed railway construction has high technical requirements. Like Mr. Daniel said before, from the code ethics of ASCE, the fundamental canon number 1 is engineer shall hold paramount the safety, health, and welfare of the public. So in this project, the smoothness of the track directly affects the operating speed, riding comfort, and safety. It is one of the key factors that determine the success or failure of high-speed railway construction. Therefore, it's important to analyze and predict the law of settlement and deformation during the construction of offline projects and after the completion. Like we know that Bandung is a basin with the great land subsidence. Land subsidence is a phenomena that has been commonly occurs in big cities, especially in Indonesia. Bandung, as the one of big cities in Indonesia, has been identified for land subsidence. The land subsidence is suspected to groundwater exploitation by the factories which are located around Bandung Basin. The Bandung Basin is a large intramountain basin surrounded by mountain range. The center of the Bandung Basin has height of about 665 meters and surrounded by volcanic areas of the Lake Territory and Quaternary. This is the historical of geological of ancient Bandung lakes that we can see that Bandung, the history is presented by the Van Bamelen, Silitonga, and Kusu Mudinata and Hartono. This event marked an important process in the development of the Mount Sunda complex. During the final quarter, Mount Sunda erupted violently to form a caldera, and then in the middle of Mount Sunda erupted of it grew Mount Tangkuban Perahu. Furthermore, the eruption controlled regional sedimentation and determined the development of the Bandung Basin landscape. This is the Bandung Regional Stratigraphic Column from Hartono and Kasumudinata. As you can see in the picture, we can see that the area of the Bandung Basin is scattered with lacustrine deposits. At the center of the basin, a layer of soft clay or organic clay is found. The report from the Directorate General of Geology explains that the sediments of the basin are alluvial and volcanic deposits that vary in composition and texture. The older, this is the land subsidence of the Bandung Basin from 20,000 up to 2009. The biggest subsidence is on Gede Bage here. And then our project made, according to the settlement monitor results of INSAR, from DK 188 up to DK 142 of Jakarta-Bandung Jakarta-Bandung high-speed railway is located in the land settlement area, and the maximum settlement area along the high-speed railway is about 140 millimeter per year. And the settlement rates of DK 116 up to 124 and 130 up to 130 plus 500 and 136 up to the endpoint are relatively high. As you can see on the table, these are the land subsidence that considerably high in SSR alignment.
I'm very sorry, Mr. Vincent, for interrupting. We have only very short time left, in 5 minutes. Yeah, 5 minutes left is fine.
Okay, Mr. Alve will continue the presentation.
Okay, thank you, Vincent. So this is the 4 cluster mentioned before. This is the land subsidence condition in high-speed railway alignment, yeah. Okay, so you can see in the table. And then because of all the settlement area, the designer of this project designed the depth of the border foundation is so deep, yeah. So you can see the average length of the border is around 50 to 94 meters depth. Okay, so this is the speed, design speed of the high-speed railway. So I will explain a little bit about the settlement measurement method. So the settlement deformation measurement points are divided into reference datum point, working base point, and settlement deformation approximation point. So this is the reference point that we have made to adjust to do the survey. Okay, so this is the layout of the reference point on Bandung. Okay, this is the working base point, and then this is the settlement deformation observation point. So we need to install this to do the survey on the structure. So you can see this is the covered structure, pier, box girder, and abutment. So on this structure, we need to install all the observation map. For the pier, we need to install the observation map maybe about 1.5 above the surface, so it can be seen by the surveyor. So this is for the abutment structure. This is the method of the observation, and then this is the frequency of the observation. So you can see even after completion of the track line, we need still to do the observation of the settlement. Okay, this is on the subplate structure for the cover. This we use some kind like settlement plate. This is the cross section of the subplate, and then there are measure rod and settlement plate. Also, this is the frequency because it's different, yeah, from the grid structure and the subgrid structure. Okay, you can see the frequency. And then this is the method of survey. Okay, so the settlement deformation observation shall implement the principle of 5 fixation. First is fixed datum point and working base point. 2 is fixed personnel. So you have to appoint the same personnel for this survey. And then the third is fixed survey instrument, and then fixed observation environment condition, and also the last is fixed survey land and method. This is the equipment that we use. This is the flow chart. Maybe you can see from the presentation that I will give you. So for us as the contractor, this is the main part of our role. So we need to complete the observation report. So the designer can do some kind like adjustment about the settlement. So this is the accuracy, and then this is the level measuring instrument must use detail level. This is the accuracy. So we want to use this DK 131 as study case. So you can see from April 2017 to September 2020, the estimated settlement is 34 centimeter. The average monthly settlement is 8.21 millimeter. This is the structure. So for the design itself, the depth of the bore pile already around 56 to 67 meters. So we don't only rely on the bearing capacity, the end bearing capacity. We also rely on the friction capacity, because it is ancient lake. So this is the long section for the depth of the bore pile. Then you can see the cumulative settlement that we have from our analysis. So the average rate of settlement of number 22 is minus 8 millimeter per month. So if on the tolerance from the designer, it just 3.33 millimeter. So okay. So
yeah,
okay.
We have only 1 minute left. Maybe we can jump to conclusion.
Okay, this is already the conclusion. As you can see, the maximum average rate for the settlement per year is 40 millimeters. So, but the actual average rate of the settlement is around 90 to 100 millimeter per year. So, in view of the problem of regional subsidies in Bandung area, so through the current monitoring data, it is found that the local subsidence is large. In order to solve the subsidence problem, the designer, in this case is CRDC, adopt the method of fine-tuning the vertical section, adjusting the height of headstone and adjusting the base. So there are two conditions on during construction and after construction. So what we can do on during construction, we can just adjust the elevation of headstone or pedestal where the bearing pad is. So before the erection of the structure, what if the condition is after construction or on operational stage? We can adjust the thickness of the base layer periodically, or for the extreme solution, we can adjust the pedestal level by jacking the box girder. And the conclusion is from this case on this project, all contractors attach great importance to the settlement of operation and measurement, especially the settlement of operation and evaluation work, which is the necessary basis for. It is also a required work for complete acceptance. Therefore, it is necessary to increase the measurement work management, ensure the authenticity and continuity of the operation data, and create condition for smooth development of the follow-up track construction. Thank you. Maybe it's
All right. Thank you very much to Mr. Vincent and Mr. Alve Yunus for such a great presentation and a very nice topics. And I believe that we can learn a lot of things from these projects. Okay, we now at the third speakers. The last presentations today entitled Evaluation of the degree of consolidation of coastal reclaimed lands based on settlement data and CPTU Makassar reclamation projects will be given by Mr. Kirana Rongsadi. Mr. Kirana is an engineer at PT Geotechnical Engineering Consultant with several years experience in various large-scale infrastructure projects in Indonesia and international. Ladies and gentlemen, please welcome Mr. Kirana.
Okay, thank you for the kind introduction, Mr. Derek. Okay, let me share my presentation. Good afternoon for all the participants. Today I would like to present one of my research with the title of evaluation of the degree of consolidation of coastal reclaimed lands based on settlement data in CPTU. First of all, I would like to give my special thanks to PT Geotechnical Engineering Consultant and also to Professor Paulus Raharjo who give me the permission to present in this session today. And actually, the full paper has been published before on Geotech Hanoi in 2019. This is the content of the presentation. We will start with the introduction, the purpose of study, evaluation method and the soil condition, evaluation result, and the conclusion. The project location is located at the west side of Makassar city, in the Makassar Street next to Makassar Port, South Sulawesi. This is one of the latest reclamation project in Indonesia. As we can see, this is the landscape plan of the reclamation work with about 150 hectares. The purpose of study is generating based on the geotechnical problem that we may face if we do the reclamation works. The first problem is the density issue of the compacted fill material, which is the sand fill. It is related to the bearing capacity and the liquefaction potential due to the earthquake. And the second problem is the substability issue along the construction period due to the existence of the very soft soil. And the third one is the degree of consolidation of the very soft subsoil, which will be the focus of this study. This study is limited only on the Sunset Quay area, which is the area inside this blue line here. The study will be evaluate based on the settlement plate data and CPTU data. So before we start, I would like to explain about the CPTU itself. So the CPTU is in general is the same with the electrical CPT. From CPTU, we can get the cone resistance. Then we also can directly measure the slip friction and also the pore water pressure. Because with the CPTU, there are what we call the pore filter. Based on the location of the pore filter, there are three types of CPTU. The first one is the pore filter located on the cone tip. Usually we call it at SU1, U1. And then the second is the pore filter located at the back of the cone. Usually we call it SU2. And the third is the pore filter located behind the slip friction. Usually we call it SU3. The piezo cone with the U2 pore filter is most common use in practical area include in this project. Then after based on that based on the measured data, we also can calculate the what we call the total cone resistance. With this equation, the A value is the cross-sectional area ratio of the pore filter, which is equal to 0.81 for the CPTU that we use in this project. This is one of the example result of CPTU result from the project. The first one, as we discussed before, there are cone resistance directly measured from CPTU. Then we also directly measure the slip resistance and also the pore pressure or U2. From the cone resistance curve chart, we know that from 0 to 10 meter depth, there is a sand layer with the QC in between 4 MPa until 8 MPa, then followed by the soft soil layer, which is clay to silty clay layer with the QT below 1 MPa. Then this is the sleeve resistance, measure sleeve resistance. And in the pore water pressure, U2, we also can draw this red line. This red line is actually the what we call hydrostatic pore water pressure. And the black line is directly measured U2. And the difference between this black line and this red line is what we call excess pore pressure or delta U. Then based on three basic directly measured parameter, we also can calculate the other parameters such as the friction ratio, which is Fs divided by Qc, and the pore pressure ratio by Q, which can be calculated by this equation. The U2 minus U sub 0, which is the delta U or excess pore pressure divided by Qt minus sigma sub V, which is the total stress of soil. This is the first method of to evaluate the degree of consolidation based on CPTU data. This has been published by Srinogoro and Raharjo in 2013 and Raharjo et al. In 2016. As seen in this figure, when the degree of consolidation is equal to 1, we get the BQ value is equal to 0.7. So when the BQ ratio is larger than 0.7, then it means the soil is still under consolidating. Then if the pore water pressure BQ is smaller than 0.7, then the soil condition is overly consolidated. So the degree of consolidation can directly calculated by using this equation. The second method that we use for evaluate the degree of consolidation based on the CPTU is the effective stress concept, which proposed by Santoso and Raharjo in 2014. First of all, we should determine the thickness of the compressible layer. In this case, the compressible layer is start from 10 meters depth until 18 meters depth. Then we should calculate the QT in normally consolidated condition. The QT in normally consolidated condition can be calculated by using this equation with the SU divided by effective stress of the soil in normally consolidated condition is equal to 0.3, and the NKT value for NC soil is taken equal to 13. Then we can get the QT value in NC condition. Then after we get the QT in the NC, we also can calculate the degree of consolidation by using this equation. QT measured directly from the CPTU divided by the QT in NC condition. The NKT equal to 13 is taken based on the publication of the Setinegoro and Raharjo in 2013, which is also by main intuition in 2018. If we calculate the NKT with this equation based on main intuition in 2018, with the BQ value is equal to 0.7, as we mentioned before, for NC condition, then we will get the NKT value is in between 12 to 13. So the NKT equal to 13 is quite good to evaluate to be used. This is the example of effective stress concept to obtain the degree of consolidation. After we get the QT for NC condition, we can plot it together with the directly measured QT, which is the blue line. The QT in NC condition is in the orange line. Then after that, we can normalize this measured QT to the QT in NC condition. So we can plot the degree of consolidation versus Z divided by H. After the normalize, we can obtain this right chart. So if the area at the right side of the blue line is the A area, and then the area at the left side of the blue line is the B area, we can calculate the degree of consolidation at each depth by using the equation of B divided by A plus B. Then we get the degree of consolidation for every depth, and then we can averaging for each depth. then we get the average degree of consolidation equal to 88% for this case. This is the example of settlement plate monitoring data. This chart is fill height versus time, and this chart is the accumulative settlement, which is measured directly from the settlement plate versus time. From that data, we can estimate the final settlement by the various method. One of it is the Asoka method, which is published in 1978. The basic concept of the Asoka method is the settlement at this time, if it equal with the settlement at this time plus at the delta time, it's same, then the settlement is finished. So we plot, firstly, we need to plot the data is ST, settlement at time, versus the settlement at time versus plus delta time. So we get this dot, then we can extrapolate this dot with the linear line. Then when this blue line crossing the 45 degrees of line, so we get that is the final settlement. The other method is one divided by time versus settlement method. As we know, the consolidation settlement will be finished after the time is unlimited. So if 1 divided by unlimited, it is equal to 0. Then we can plot the settlement, measured settlement from the settlement plate in this chart, and we extrapolate with the linear line until cross the 1 per time is equal to 0. So we can get the settlement final is about 1 to 1.85 for this case. And the third method is by using the hyperbolic extrapolation method. First of all, we should plot the time versus time per settlement with time. Then we get this red dot, and we can draw this line. Then we get a and B value. So after we get A and B value, we can estimate the final settlement with the asymptote of hyperbolic method with this equation, 1 divided by B. And also we can plot the hyperbolic extrapolation with the measured directly settlement plate data, like the figure in right side. Okay, this is the evaluation result. The settlement plate monitoring in the Sunset Quay area is monitored in 10 locations, and the CPTU test is 13 locations, is done in 13 locations in Sunset Quay area. This is the result of the settlement plate data. The degree of consolidation we got is in between 50 to 94%, depends on the location of the settlement plate. But if we look at the result, this 3 method is giving a quite consistent result. Then the degree of consolidation based on CPTU data, we get the average between 75 to 99%, and also give the quite consistent data. This is the comparison between the degree of consolidation based on BQ and based on the effective stress. And this is the 45-degree line, or as we seen the difference between these two methods is quite small. So this 2 method is quite reliable to be used.
I'm sorry, Mr. Kirana,
Okay.
For interrupting, because we have a limit of time. I think we only have 2 minutes. We can jump to a conclusion, maybe.
Okay. This is the settlement plate and with the CPTU, which is give the quite consistent result, except for SBO112. Okay, this is the conclusion. The soil condition in this project is dominated by very soft to soft silty clay, QT between 0.5 to 1 MPa, with various thicknesses between 2.5 to 10.5 meter. The degree of consolidation from the settlement plate data is between 50 to 94%. Besides, the degree of consolidation from CPTU is between 75 to 99%. Thus, at some location, the reclaimed land is not ready yet. In general, both the settlement plate and the CPTU is quite reliable to use for estimating the degree of consolidation. That's all for today. Thank you for your attention.
Thank you very much, Mr. Kirana. And everyone, we are now at the end of the presentation sessions. And we open the discussion session, maybe about 15 minutes. And yeah, so we can, if any questions from the audience, let me check. Is there any questions? Yeah, I think, yes. So this is the first question, I think. From Aswin Lim. So I just read here from the comment box. Hi, my name is Aswin from Prahiman Catholic University, Indonesia. The question is for Mr. Alve and Mr. Vincent. I'm wondering, how is the performance of the peer foundation from your presentations? It seems that the peer settlement consists of two factors: land subsidence, working load, and the sum of land subsidence might not be considered in the pile bearing calculation. Also, it might have the potential for negative skin frictions. Where negative skin friction occurs when the settlement of the adjacent soil is larger than the pile settlement. Please advise how this issue would be tackled. Thank you. So please, Mr. Alve and Mr. Vincent.
I cannot read the question, Mr. Diastra. So where is the question?
Maybe we can show that in the screen.
From who?
That is in the chat box.
In the chat box. Okay.
Yes.
Okay. So, the first one is, so, okay, you are correct. The settlement consists of two factors: the land subsidence itself and also the working load of peer. So, okay, our Chinese designer still figure out why the settlement still happen, yeah, because on their design, the depth of the board pile, the diameter of board pile, and also the number of board pile is so it's so huge, yeah, compare other our infrastructure projects such as elevated toll road of Jakarta-Cikampek and also like rail transit on the Jakarta, Bekasi, and Depok. So our Chinese designer already considered that, but they haven't still figured out why the settlement is still happening. That's why right now we are still in the during construction phase, yeah. So we as the contractor still do the observation phase. So we want to know how much is the settlement still happen, and until when. So maybe that's why we have two solutions. First one is on the during construction we can adjust the level of the bearing. The pedestal or the pedestal where the bearing pad is laying, and then if after construction or on the operational stage, we can readjust the thickness of the ballast. Yeah. So periodically, maybe after 1 year, there are settlement happen, then we adjust the ballast, and the next year we can adjust the ballast. And if the settlement continues, maybe the extreme solution is we jack the girder and then we add the thickness of the padstone. So so far I know there is there are the solution of this case. Yeah. Okay. Next one, Mr. Destra.
All right, thank you very much, Mr. Alvinus. I hope that answered the questions from Aswin Lim. Okay. All right, next. Okay, so we have another questions for Dr. Daniel. So the question is, what is the main challenge on incorporating the proposed performance-based concept based on risks in practice? Do you think our current design provisions are compatible with this? So please, Mr. Daniel.
Oh, thank you for the question. What is the main challenge? Piece proposed performance based concept in practice. So in the US, it's already implemented in for projects that dealing with big risks such as MRT under. So in San Francisco, there is like it's a Bay Area, and so there is there is a rapid transit. It's called a BART system that goes underneath the underground and then under the ocean. So yeah, for that kind of projects, so this kind of performance-based design is already implemented. And for the current practice, especially in Indonesia, I think the main challenge is the code. And because it's not in the code, so I guess the practice will not do that because the code said you don't have to do that. So I think that's the challenge. And do you think our current design provisions are compatible with this? Oh yeah. And so this is not a new code. So this is just a framework where we have to think probabilistically, where we have to quantify all the uncertainty of parameters. For example, undrained shear strength of soil. So instead of using, okay, my undrained shear strength is 25 kPa, instead of using that, this approach suggests that, okay, the mean of my undrained shear strength is 25 kPa, and the standard deviation is, say, 5 kPa. So using log normal probability distribution, I can estimate the probability of collapse of my buildings or my slope if the undrained shear strength is only 20 kPa is this percent. So yeah, so this is not a new design provision. This is not the new code. This is just a framework and how to calculate all the results. So yes, it is compatible. So that's it.
All right, thank you very much, Dr. Daniel. I hope that answered the questions for these questions. And yeah, we have another one. So this one is for Mr. Kirana Rongsadi. What are the most determining parameters and challenges doing a reclamation project in an area? Okay, that's the question.
Okay, thank you for the question. The most determining parameter, I think, is the existence of the soft soil, usually at the at the base of the our field placement. And the challenges is it will be so quite much the geotechnical problem, including the density of the sand field, and then the slope stability, and also the degree of consolidation. What I mentioned before. That's my answer. Thank you.
All right, thank you very much to Mr. Kirana. And I guess if we have another questions or no? Yes, we have. All right. So we have two questions for Mr. Alve Yunus. So the first one, what is the main criteria that has been used as a tolerant settlement due to construction for pier structure? And the second one, how do you predict long-term settlement during the operation period? And what are the possible consequences to the structure in the future?
Okay, thank you, Mr. Gastra. So for the first question, whole of the code and then the technical specification on this project we use from the China code, yeah, for the high-speed railway construction. So the criteria that has been used as tolerant settlement is from I'm sorry, what is the main criteria that has been? Okay, so on the technical specification on China's code, yeah, there are several tolerance maximum of the settlement that can be allowed. Yeah, so maybe there are several conditions where you can the structure itself can have a settlement, and then you just adjust the level of the the structure, mainly on the easiest part is the thickness of the ballast. Yeah, so there all of that is already on the Chinese part of high-speed railway, but the main issue in this project is the settlement on Bandung area is bigger from all the Chinese spot that have been used by us. So that's why we are now in still on the observation phase. Yeah. So we periodically measure the settlement every month and every year. So maybe I don't know. Maybe for the next 5 years we still do the observation. So so we can know when the settlement is already start. Yeah. Or keep continuous. So that's why it is still become a study from uh, the Chinese designer. So maybe the temporary solution that we can do for now is just adjust the level of the structure because there's nothing wrong on the design from the Chinese designer. That's all I can say, yeah, Mr. Jastra, for now.
Okay, thank you very much to Mr. Alve for answering the questions. And I think we don't have time enough for more questions and due to the limited time we have. So thank you very much to all the speakers and thank you very much to all the audience for a very fruitful discussion we have today. And I would like to remind to the audience that we have delivered in the chat box a survey, a link for survey. So please, if you can spare time to complete the form. And also, yeah, now so we have reached the end of our sessions. On behalf of our team, I would like to thank you once again, all the speakers, Dr. Daniel, Mr. Alve Yunus, Mr. Vincent, and Mr. Kirana. And thank you to all of you for joining us today in this international webinar via Zoom. This international webinar is brought to you by the Asian Civil Engineering Coordinating Council, ACECC, in collaboration with FIB, YMG, Young Members Group, Indonesia. Please note that the next webinar series will be hosted by Nepal in June next month. So please save the date. So we are looking forward to seeing you again. I'm Frederica Diestra. Bye now.